This is page 10 of 8.1.5a. We'll now motivate why we are interested to convert X, which belongs to an abstract vector space V, into a coordinate vector xp using the basis B. First, this mapping of converting X to xp is 1-to-1, means that we can get back X given representation in xp. Okay, so there's no loss of information. It's 1-to-1. We'll prove it in the next page. So graphically, abstractly, what are we doing? Well, we have a vector X belonging to this vector space V. We perform a linear transformation, and it's linear, and we'll get a coordinate vector xb in Rn space if vector V is spanned by B1, B2 until Bn. It needs n dimension. It has n vectors that spans the space. Why do we prefer to be in xp, a coordinate vector? Because remember that this is a column vector, and we are very familiar with column vectors. We know how to deal with column vectors. We know how to use matrix multiplying by column vectors. So we know how to add column vectors, scale column vectors, much better, more than when V is abstract. So what can V possibly be? Remember that V is an vector space, and anything that satisfies the axiom is a vector space. One example of vector space is P2. Polynomials of degree at most 2. Polynomials are a times x squared plus b times x plus c, and this is of up to degree 2 because we do not have something to the power of x cubed. Now a, b, c's are the values associated with these polynomials, and they can be represented as a vector a, b, c. This is R3. This representation is x as a polynomial. This representation is x as a coordinate vector. And this transformation of x to xb, nothing is lost. And we call this isomorphic. xb is isomorphic to x. And one of the reasons we prefer to deal with xb is we are more familiar with coordinate vectors. In this slide, there's a short proof of showing that this 1-to-1 linear transformation from x to xb is linear. So to prove linearity, we have to prove these two operations preserve the linear structure, meaning that the sum of two vectors in the b coordinate and the scalar product of the b coordinate observe or preserve addition and scalar multiplication. Please go through the proof by yourself, and then we are done with this